Hi everyone and welcome to another video. Today we're going to be talking about what are pure virtual functions and some of their uses. Specifically, I'm going to be looking at abstract classes, interfaces, and identifying what a real type is when you're casting. If you checked out the last video, we were talking about up and down casting, and we said that reality can be whatever we want when we do things like reinterpret casting, and casting in general is pretty trippy, right? Well, we also said that when you're casting up and down, you have to make sure that specifically when you're downcasting, so when you're casting a parent pointer to a child pointer, so parent class to child class, when you're doing that kind of casting, that even though you have a parent pointer, it's really pointing to a child, because if it's still pointing to a parent, so you got a parent pointer point to an actual parent, and you cast it to a child, you now have access to all the fields and functions that the child class has, which the parent doesn't. So if this is really a child, if this is really a parent, then it's going to be in trouble and really bad things are going to happen, right? So you always have to be careful what you're doing when you're casting. And one of the things that you can do to be safer, unless of course you also like to live dangerously, is that you want to be able to identify whether a pointer is really pointing to a parent or child. And one of the ways that you can do that is with virtual functions, and I'm going to show you that today. Okay, so let us jump in and go ahead and get this out of the way. So we already introduced you to the concept of virtuals and virtual functions. So let's just kind of summarize what abstract really is. So when you have a class, we just call this like a normal class, run-of-the-mill class, good old classes, And your class can have functions in there, so you could have like a little foo in there. And you could have variables in there as well. You could even have your function cout variables. You can make it public, private, protected, whatever it is that you want to do, right? But you have your functions and they're all cool and nice. This is just a normal class. But we're past this. We're not looking at stranger things, right? So in this case, let us go ahead and make this into an abstract class. And I'm going to do that with a single keyword. And surprise it or not, which you shouldn't be, unless you're surprised I can't spell it, you just got to put in virtual to a function. And the moment that you have a function that is virtual, then this is now considered an abstract class. Okay, now that's just a term. It's not really doing much, but you have to know what virtuals do, right? So to refresh your mind on what a virtual does is instead of having your compile time binding, you have runtime binding. What that means is that at compile time, normally when you're doing something, if you have an object of class A, if you say something like A, what would you, let's make pointers, because we like pointers. And if I'm calling the foo function here, what's happening at compile time is that it says, well, you're calling foo, right? Okay, cool, very cool. I'm going to associate that function call with the code from the class A, right? And that connection is happening at compile time, and that's an optimization thing. If you have your up and down casting, and you have your parent and child class, and you end up trying to make you have a child pointer pointing to a parent class, well, that's really bad. Other way around. So if you have maybe a parent pointer pointing to a child object, and you call it the foo, which may be different in the child than it is in the parent because you overrode the function, then you're going to call the wrong function, right? Or if it's a destructor, you're not going to deallocate memory correctly because, like, let's say we had a pointer in here which was dynamically allocated in the class, so like a dynamic variable, and then we had this pointed with a parent of this A class, then you would call the wrong destructor, right? So we already talked about that, so hopefully this is just review for you. But ultimately, you add virtual because now those checks are done at runtime, kind of like dynamic cast is doing runtime checks, and it will be able to call the right function, okay? So virtual allows you to defer that to runtime, and some languages like Python just make everything virtual to make life easy, but that does make it like there's a higher chance that things can go wrong at runtime. So you're not getting a free lunch, you're just deferring your work to runtime, which means that any errors could show up at runtime, which ideally the best way to approach coding is you want most of the errors to show up when you're making the code, not when you already put the code in production and then you screw something up and then like your entire system goes down because you couldn't find that error when you're making the code. So sure, being able to leave things to runtime is nice for getting things up and running quickly. Not so good when you're trying to make code that is robust, right? So pros and cons, like anything in life. So that's an abstract class. Not that exciting, but very useful, okay? So we also have this concept of interfaces. And interfaces, and this is where, of course, talking about C++, right? Because interfaces is not really a C++ thing, but you know, if you think of like an interface in Java, that's kind of what we're trying to mimic. But it's not really, it's more of like a terminology jargon than it is an actual concept in C++. And for you to be able to understand that, I need to show you what a pure virtual function is and what it does to a class that has it, okay? So, suppose that I have another class called class B, and my class B is only going to have a function in it, okay? And this function is going to be virtual, but it's going to look really weird. In fact, I'm going to call this class ent. You know, we kind of got that theme going with the game, right? Bam. This is my class right there. You're like, whoa, what is that function? Like, that does not look like normal code. Like, what are you doing? Equal to 0? Question mark? Question mark? Question mark. Like, what is this stuff? This is what's known as a pure virtual function. What it is, it's a function that does not have a body to it. It's just a function. The name exists out there in the class, but if you try to call this function, it's going to give you an error because it's not defined. Furthermore, you could technically do this with a normal virtual function. So like, for example, here, I could do this, and the code will compile. As long as I don't call foo, then I get away with it. The moment that I have a piece of code that calls foo, the code no longer compiles and tells me that the body is not defined. But the big difference between using this and the bottom one is that I can make as many objects of A as I want, and the code will run just fine, as long as I do not call it. So if I have that line of code, the code won't compile. If I remove that line of code, the code compiles and runs, which is kind of bad because at the end of the day, you're like, you have a function there, and like the code compiles and runs, but like the moment someone in the future wants to use a library and decides to call foo, then everything is going to blow up because it will not compile and say that the function is not defined. So why would you want to do that, you ask? Well, the reason why you want to make a function that you then don't want to define is because you might be trying to build a project where you sort of have a base class that's going to have a blueprint of all of the requirements that the derived classes should have, but each derived class is going to fill it in a different way. So again, let's say you're making a game. So you want all of the objects of the game to have a name and maybe to have a health value, like an HP value, hit points or health points, right? However, the derived classes might handle that differently. Or you may have a function that is called attack, so that the player can attack. But like, you may have a class that has magic power, so their attack is different than the class that is like a melee class or a weapons like a swordsman class, right? So you want to sort of create. I don't want to use the word template because templates are something in C++, but you want to make a blueprint or a template of what you want a class to have, but you don't necessarily want to fill it in right now. You want to defer that to the derived classes. So you want that consistency that like, okay, all my derived classes should have an attack function, should have a health function, should have a speak function, but I'm not going to do that yet. In fact, one of the examples that I used to give if you watch one of my old 202 videos is the animals. So maybe you want to make a farm, and the parent class of the farm is just going to be called animal, and you have a speak function, and you have a sleep function, okay? But you don't fill those in. You can actually fill in the sleep one, but you don't fill in the speak one because, you know, when you make a derived class of that, you might call a pig, or you make a chicken, or you make a dog, and the chicken, the speak function in that is going to make a different noise than the dog is going to make. So like the speak one's going to be like see out. How would you write with a chicken? I guess like c like I guess, I don't know. Or the dog, which is there because you just put bark, or the pig, which you just put oink oink. Okay, so you can do that in the derived classes. So all you're doing by putting it in the parent class is you're saying, okay, I want these functions to at some point be defined, but not right now. So, but I'm making this standard here, okay? However, when you're doing it like this, sure, you're sort of creating it, but you're still not requiring them to fill them in. So, the code will compile. That's where pure virtuals come into play. In this scenario here, when you have your function as a pure function, like the pure virtual function, it will not let you create an object of this class. So if I go in here and I go in and write like what is called ent. So if I try to make a class called ent a, whether it's a pointer or whatever, the moment I do this, it gives me an error because we have a pure virtual function. So in that case, you can't even define it at this point because you've made it here. So what you would want to do is in your derived classes, so let's just do a derived class called player that inherits from ent. In this class here, I can go ahead and actually create this function proper. So I can say something like, actually I don't think you need to write the word virtual now. I think you just go and actually write code by putting the curly braces. When you do that, what is happening now is this is no longer a pure function. Again, you might need to write virtual, I don't remember, but either way, if you write it or not, the point is you're now defining this function, so it's no longer undefined. Now, if I try to make an object of player, it will let me. So the fact that it doesn't let you make an object of entity may be a good thing, because like, if you're working with the farm example, there's no such thing as an animal. There's pig, cow, chicken, dog, but there's no just animal, right? That's just like it's a class that you need to have for your hierarchy, but it's not a class you actually want to make objects out of, okay? Similarly here, you have players, you have NPCs, you have obstacles, etc., but you don't have a thing that's just an entity. It has nothing. Like, what is that? What is an entity? That's like some meta physical thing. Like, no. You can have things from that class, but not that class itself. So pure virtual functions allow you to do that. And the only caveat is you have to define them in the derived classes. Otherwise, the derived classes would also be considered abstract and basically not built. Okay? Or not built if you make an object of them. Finally, interfaces themselves is just the classification of a class that is strictly made of pure virtual functions without any member variables. So class ent here is actually an interface. So it's simply a naming terminology, because if you do happen to have a variable or you have a mixture of both pure virtual functions and just normal functions in there, that will be considered an abstract class. So the name interface is reserved exclusively when you have a class with no variables, only functions, and those functions have to be pure virtual functions, which you put with this syntax here. I know the syntax is weird. I can kind of see why they did it, because the equal zero, kind of like makes you see that there's nothing in it. But it's just, it could have been done better, but I can't really think of a better way. So yeah. So yeah, that is pretty much what pure virtual functions are and how it works with abstract and interfaces. Finally, for the identifying, the types, here is a good advice for you. So let's take this class that we already made and just bring it down here and slightly modify it. So instead of calling it foo, I am going to go ahead and call this what am I. Okay, so now we have an interface, which is entity, and we know we can't actually make objects of this interface. But when we make derived classes from it, let's just make two of them. We're going to call one player, as we did before. And we're going to make another one called obstacle. I'll just say OBS because it's a lot of writing. So now I can, of course, add as many variables and functions as I want here, but I want to make sure that I also define the pure virtual function. So I can do that by just writing here my and actually, sorry, I don't want to make that void. I want to make that return something like a string. And then here I just go ahead and say return, and I'm just going to say P for player. And similarly here, O for obstacle. I mean, I would actually put player and obstacle fully, but for now that's fine. So this piece of code here is pretty cool because you can make an array of entities. You know, you can make an array of pointers and then start filling them up with actual players and obstacles. And whenever you want to do some casting, so obviously everything is going to be stored as a parent. So everything's going to be upcasted when you throw it in there. So like when I go in here and say something like, let's just make it an array of them. So entity pointers, we'll call this the board. And we're going to assign it an array. Let's just make it a one-dimensional array for now. New entity of size 10. Okay, so now we have an array of pointers. And so, you know, if you want to start filling it in, you could say like, okay, well, this spot here is going to get a new player. It's called player, yeah. And then maybe like this spot here is going to get a new obstacle, and so on. You could do that with different ones, you know. Or if you move them around, then you can swap the pointers to different spots, etc., etc. This is upcasting, all right? Right there, there's upcasting going on. I'm not saying dynamic there. You probably should put dynamic there in this, but I don't think it'll require it. But there's upcasting going on. So when it comes time to actually, you know, let's say that like, you know, you're trying to make the player do something, so you actually want to call a function from the player class. You need to first downcast it to a player pointer so you can actually access the features. So you would want to make a pointer called player pointer, I don't know, P, and then you need to downcast it. So you need to go and say dynamic cast to a player. I'll put that in the next line. Let's make that bigger. To a player pointer. Entity, I don't know, 5. Let's say 5 was a player, okay? All right, well, no, let's just use the one that we did because I don't want to confuse you too much. So 2 there. Okay, so if I do that like that, I am now able to actually access the player feature. So let's say a player had in here an HP var. So we have a little int HP. Okay? So now that I've done this, I can go ahead and say something like PHP gets PHP minus minus, like, you know, they lost. Well, actually, we'll fail. That will not do anything. I should do minus minus for that, but here just do -1, whatever. Okay? So in this case, that's decreasing the HP of the player. This is a upcast, or sorry, this is a downcast because you're casting from the entity class to the player class. However, you're doing this because you know that that position has an entity in it that is actually a player, an entity pointer. But what if you don't know? What if you want to check it? What if you want to be safe? You don't want to play dangerously. You don't want to live dangerously. Well, that's what your what am I function is going to do. So your what am I function, you know, not only is it useful because it prevents you from actually just trying, like if you try to in here do something like, you know, entity 5 is just getting a new entity. That code will not compile. It'll be like, yeah, no, you cannot instantiate an object like with a pure virtual function in it, an abstract class there. So interface. So that's not going to work. So that's one good thing. But in addition to that, when you say if you write in an if statement here and say something like if entity 2 arrow what am I is equal to P, then you run this code. Because here's the thing, this is a virtual function. It's pure virtual function, which then, what was instantiated or was actually completed, defined in the derived classes, right? But because it's virtual, it'll call the right one. It's not, even if this was like 5 layers deep in like child of child of child of child, because it's virtual, it knows which one to call based on what the object really is. And so because of that, it's going to call the right function and is actually going to return to you what you overloaded it with, which in this case is a P. So this is one way to check what this object really is and to confirm that it's a player. And if it is, then you do the casting. You don't do it before because you're not 100% sure. So it's a way of checking it. So this is what I meant last time when I said that you can use your virtuals and your pure virtuals to be able to identify the object type before you do your casting to be extra safe. Okay? So that concludes the video. Hopefully you now have a good understanding of virtual functions between this and what we did in class the other days. And I thank you all for watching. And good luck with your assignments, I guess. All right? Take care. And until next time.